Assalamualaikum and good day. So today I would like to present my final year project, which is developing AI based network intrusion detection system with real-time basic threat mitigation. My name is Muhammad AIZAT bin IDRIS and I supervised by my lecturer, my supervisor, which is Shafida binti Abdul Halim. Before we dig into the technical details, this slide provides a high-level overview of the project scope and value. The key takeaway here is that we identify a clear problem, which is the traditional intrusion detection system are struggling against modern cyber threats. Our solution provides a unique value proposition by creating an AI-powered system that not only accurately detects threats but also mitigates them in real time, which is shown in the lean model canvas. So, what is the core problem that we are trying to solve? So, as we mentioned earlier, traditional network intrusion detection system or NIDS, they are faced three major challenges. First of all, they are struggle to detect new and sophisticated attack like zero-day exploits because they rely on known signatures. Besides that, they often produce a high number of false positives, which creates unnecessary alerts and cause security teams to miss real threats. And finally, most traditional systems are passive. They can only alert an administrator. They lack the ability to take immediate action to stop an attack. That leads to our project goal, which is to overcome this limitation by developing an intelligent NIDS which is accurate, adaptive, and capable of automated threat mitigation. Next, to achieve the goals, I have set the objective in this project. The first one is to develop a functional AI-based NIDS that can perform real-time threat detection and basic mitigation, specifically through IP blocking and real-time alerts. And second objective is to evaluate the system performance by performing the accuracy testing and also functionality testing. For this project, the scope of this project was focused on detecting three common but critical classes of attacks, which is port scan, denial of service, and also the other one is man-in-the-middle attack. The entire system was built using Python that powered by a hybrid AI model and features a user-friendly graphical user interface that built with Streamlit. For this project methodology, they have the systematic order in completing this project, which is in this project. I follow the waterfall model through distinct phases, which is from the gathering requirements until the final documentation. A crucial first step was dataset preparation. I have used several well-known public datasets that I obtained that include NSLKD and CICIS 2018. This is to ensure our model was trained on diverse and realistic network traffic. This data then cleaned, normalized, and carefully balanced to prevent any bias in AI model. For the AI development, I have created a hybrid assemble model, which is this approach combined the strengths of three different algorithms, which is random forest for its robust, support vector machine for handling complex pattern, and deep learning model, which is LSTM, which is excellent for analyzing sequential data like network traffic. Next, my system. This is show the system workflow. This diagram illustrates how the system works. So, the system works by begins with the live network traffic being collected in real time using Scapy. The system then analyzes this traffic using our AI model, and also the analyzation is consists of AI detection and also combined with the rule-based detection to ensure the capability and also efficiency in the predicting the network traffic. Then the system that analyze the traffic also log the data for forensic purpose. Based on the analysis, the system detect threats. If a threat is found, then the system immediately proceeds to mitigate it through two automated action, which is sending user alerts in real time in the dashboard and also perform an IP blocking to stop the malicious traffic in the live network that has been analyzed. For this project, I have performed two testing, which is the first one is accuracy testing to see the performance of the AI model itself. So based on the result that's being shown, there is a key part of the evaluation from the testing that have been made. So the first one figure, which is show the full assembled classification report. As we can see, the model achieved an excellent overall accuracy, which is 90%. As you can see from the matrix, it correctly identified 9,307 attack instance, which is the true positive, and 3,644 normal instance, which indicates the true negative. The low number of false positive and false negative demonstrates that the model is both highly accurate and reliable. The other one testing that I have been done, which is functionality testing. This testing is to ensure the system works in a real-world scenario. So I have performed the functionality testing to see whether this system is working well. So from the screenshot is shown in the slides, it shows the real-time alerts that generated by system when it successfully detects various attacks, which is we focus on the 3 attacks, which is port scan, denial of service, which is the SIM flight, and the man of the middle attack. So byte detection is only half the solution. The system also took immediate action. This final screenshot shows the block IP address, which is proof that the system automatically blocked the malicious IP to neutralize the threats. Next, we will move to the system demonstration, which is in this project. I have used the Python library, which is Streamlit, for the user interface. Streamlit is a web-based library that can provide a user interface. So that based on the user interface, I have 2 functions, which is real-time monitoring and also offline analysis. So first we go through the real-time network monitoring, so the user can choose the network interface that they want to capture, and when the start monitoring is pressed, the live network traffic chart will be appear to show the network health, and also the system will show the protocol distribution according to the network traffic that been captured on the session. So the main function that the network IDS, which is the security alerts from the interface, it shown the recent security alerts that have been captured by the system itself. So the captures that consist of timestamp, type of attack, source of IP, destination IP, and also it detected from what devices to the what port according to the attack. And we can see to show the real-time alert, I have performed a scan in the Kali Linux, which is nmap scene scan, and then it show the real-time alert to the user, indicates that my system work properly, and also it have the block IP address table which is show the IP that blocked from the malicious activities. Besides that, in the real-time network monitoring, it also show the network statistic, which is the top source IPs and also top destination that may help the network administrator with the network analysis. And then the other one function that I have in the system, which is offline analysis. In offline analysis, I have 2 functions, which is pickup analysis and database insight. So for the pickup analysis, the user need to upload pickup files that have in their devices. So in these cases, I choose the pickup file that consists of DOS and also port scans. So the model will be analyze the pickup file to show the analysis result with the important information of the pickup. So it show the attack also that consists on the pickup. Next, for the database analysis, user can choose the date, the range of date to see the alert in selected period, so that it is very useful for the forensic analysis. So the interface also show the summary of the packet and also alert type, top attack source, so that it can show clearly about the incident that happened. Besides that, I also offered the CSV report to be downloaded, so that the log can be used for the future use by the forensic analysis or maybe the model training. In conclusion, this project that achieved what we need from the objective, which is the first one is I have successfully developed a functional AI-based network intrusion detection system. Besides that, this project also achieved high accuracy, which is 92% in threat detection using a hybrid ensemble model. Furthermore, I have implemented real-time threat mitigation through automation, which is IP blocking and real-time alerts. Last but not least, I have created a user-friendly GUI with both live monitoring and offline capabilities for the forensic purpose. While the system is effective, I have recognized its current limitation, including a focused attack scope and static AI model that doesn't learn continuously. So this leads to exciting opportunities for future work. And I plan to expand the system detection capabilities to cover more advanced threats like ransomware. Besides that, to make the system better in the future, I can integrate with the network level firewalls for more comprehensive and also network-wide protection. And finally, implement an ML ops that would allow the AI model to be continuously retrained, ensure it stays effective against new and emerging threats. Last but not least, that's all from me. Thank you for your time and thank you.